To a new video of the Fourier Transform lesson. In this case, in this occasion, we are going to do exercise number 3. You can see it over here. It asks us to calculate the Fourier transform of the signal shown in that figure. So this is a very easy one, although the first time that you see it, it may seem quite difficult for you to imagine how to do that, but once you have seen that, you will clearly see that it's something really easy. Okay, so the trick here consists in realizing that this signal is made out of two signals. One is the square part of the signal that I am here putting in blue. Okay, this signal that I am putting in blue, it's a well-known signal. It's a pi signal of amplitude 2, and it is displaced to time 3 seconds, which means that here we have to displace to the right 3 seconds. So we put a negative to displace to the right and 3 units. And in the denominator, remember that we put the total width of the pi signal. In this case, the total width is 2 time units, so here we put 2 time units. So this is the blue signal. And then we have a triangle over here, signal, that can be written the same as a triangle of amplitude 1. So we put a 1 here, and then a triangle which is also displaced to the right 3 units, and the width is 2. But remember that in the triangle, in the denominator, we do not put the total width, but we just put the half width. So in this case, as the width is also 2, we put 1, because in the triangle we put half width. So our signal x of t is both signals together. This is x of t. So when we go ahead and we do the Fourier transform of x of t, which is what they are asking for, which is x of omega, we only need to do the Fourier transform of the blue signal plus the Fourier transform of the green signal, which is tantamount of doing the Fourier transform of this and this guy, that we perfectly know because it's one of the Fourier transforms that we do need to be familiar with, very familiar with. So the Fourier transform of the pi function, remember that it was 2 times, put that here, it's 2 times, which is the amplitude, times the total width, in this case is 2, and then we have a sinc function of, here we put again the total width, and then omega, the angular frequency, divided by 2 pi. But as it is displaced 3 units to the right, remember that for using the property of the Fourier transform, when we displace any units in time, we the effect in the frequency is getting an exponential, which is also -3, because we displace -3, -3 jw. So this exponential term accounts for the time displacement. And then we go for the green part. So the green part is also the amplitude, in this case is 1. Time, in this case we put half the width, which is 1, and then sinc square of the half the width, omega divided by 2 pi. And also, as it is displaced 3 units to the right, we need to, let me go here to the right, we need also to put an exponential term, which is, if you want, is j omega, and then we put here the displacement, which is -3. Okay. So, well, you can reorder the terms and put it as you want, or as you need for any future use. But basically, this is the solution. Okay, so easy one. Of course, easy when you see it the first time, but I hope that is clear. Thank you very much for your attention, and see you in the next video. Bye-bye.